Alright, so we're going to start looking at proofs here. In a proof, they're going to give you a picture, and then they're also going to give you some given information to help you solve what they'd like you to prove in the very end. So notice they give us AD as, this means parallel to BC. So here's AD, here's BC, we know those are parallel, and then AD is also congruent to BC. Now we got to prove that AB is congruent to CD. So looking at the next piece of a proof, we then start to write any conjectures, any statements that we have, and then we have to write the reasons for why we believe those things. A couple of side notes here. One, as I told you before, this is the sign for parallel lines. Then we've got the sign for perpendicular. Notice it just looks like parallel and perpendicular lines. And then finally, when you show two triangles are congruent, you can state that other portions of those congruent triangles are also congruent based on what is called CPC-TC. And what that CPC-TC stands for is corresponding parts of congruent triangles are congruent. Now back to our proof here. Notice our first two statements are that AD is parallel to BC and AD is congruent to BC. Why are those reasons? Because they're given. They told us that at the beginning. So these two become our first two statements, and we just state that it was given. Then at the very end of this thing, we're going to have to prove that AB is congruent to CD. Now also in proofs, they tend to number each statement that you go through. And they also number each reason. You'll notice I got a little lazy and didn't write my numbers for the reasons, but they'll just match up like this goes. Okay, let's begin to solve this thing. So what I did, because I knew these were two parallel lines, I drew a line connecting D and B, just creating two triangles here. And generally this line is called a transversal. So this is the symbol for parallel lines, and notice I've extended it just to show if these continued on they would never intersect. And then there's my transversal from DB. And you could also extend that if you want as well. Now we're going to start to use some of the math we know to solve this puzzle, to prove what they'd like us to prove. Now remember, angle DBA here and angle BDC have to be congruent, as we know, because alternate interior angles have to be congruent. And then the same has to go for these other two, because they're opposites and on the inside of the parallel lines. They also have to be congruent, because alternate interior angles have to be congruent when you take two parallel lines and cut them by a transversal. Now alternate interior, if you haven't learned it yet, are just on different sides of the transversal line, but they're both inside the parallel lines. And we can see it in a different way. Sometimes it's written sideways, and our picture is turned a little bit. So turn back. Notice these are both inside the parallel, but on opposite sides of the transversal. So coming back, we're going to start to write that. Here's our statement. We said that the one with the one arc, and remember that's how you show congruence in angles. We said this angle has to be congruent with BDC, the other angle with one arc. And then our reason for that is definition of parallel lines cut by a transversal. There's our picture again, and we're going to write the second angle as well. That means the one with two arcs is also congruent to the other one with two arcs, because the definition of parallel lines cut by a transversal. So remember, this is where we started. We had a blank space here. We were given stuff, but you might draw several different pictures. Here's another picture I drew where I showed the parallel lines and the transversal. Here's another way you might show it if you want to redraw your parallelogram. And you might also draw it as two different triangles, which is okay too, because in each picture you're going to see something different. And so several pictures is a great way to stay moving forward and getting to where you need to go and seeing the different math that you need to use. So I definitely recommend several different pictures, especially as you're trying to do proofs, because they're hard enough as is. you might in your pictures then show the same thing. We showed that these with two arcs are congruent with these with two arcs. Then the one arc is congruent with the one arc. And then by reflection, of course, DB has to be congruent to DB because it's the same line. So that transversal line has to be congruent with itself. And you can think of this as two triangles that were reflected. Okay, so when we come back to our thing, we can now say BD is congruent with itself because of reflection. There's our picture again. And there's another picture. Remember, we have several different pictures showing this. You'll notice we now have shown that this angle, this side, and this angle are congruent with this angle, this side, and this angle in both triangles. And if you remember in math, that's called angle, side, angle. And if you have two triangles that have those types of congruences, then you can say the entire triangle is congruent. So ADB has to be congruent to CBD because of angle, side, angle. Now if this is true, then what they wanted us to prove, AB is congruent to CD, also has to be true. Because once you've proven the two triangles are congruent, then other parts of those triangles have to be congruent as well, even though we had nothing telling us that those measures were in fact congruent. So looking at your picture, you can just see that AB has to be congruent to CD. Those are the ones that match up. And it's because of that CPC-TC, which just means corresponding parts of congruent triangles must be congruent. And there's that statement again. And there's the picture. You'll notice CD was the bottom, AB was the top. Those must be congruent. And we already knew that the other two sides were congruent. So if you wanted, you might have also been able to use a side angle side. There's several different ways to prove different things, but this is the way we've shown our proof.